Today we are going to look at section 4 of chapter 8, which is the last section in this unit. In this section, we are going to be looking at angles of elevation and depression. So what we are going to be doing is with these problems, we have word problems. We are going to be using what we've been working with in section 3 with our trig ratios. Okay? It's just a word problem, so we're going to have to take the information from the word problem, draw a right triangle, label that information, and then figure out what we can do with our trig ratios to solve the problem. So when you open up the angle of elevation flat, it says when looking up to an object, the angle of elevation is formed by an observer's line of sight and a horizontal line. So when we look at the diagram they have given us, okay, that angle of elevation is formed by the observer's line of sight. Okay, so our dinosaur, instead of looking straight ahead, which is that horizontal line, the dinosaur is looking up to the top of the tree, and that is our angle of elevation. I can see if I draw a vertical line down my tree, okay, I then have a right triangle, and I would be able to use information from our trig ratios to be able to solve depending upon the information they give us. Okay, so we're just applying our word problems to be able to use our trig ratios. So let's take a look at some examples. Number 1 says that a dog is standing 5 feet from the base of a tree trying to catch a cat that is 16 feet up the tree. Okay, so we need to draw some sort of a diagram. So I've got a dog here. The dog is 5 feet from the base of the tree. So our tree goes up, and up the top of the tree we have a cat. So I can see this right triangle. Okay? That cat is 16 feet up the tree. We want to find the angle of elevation from the point the dog is standing on the ground to the cat in the tree. So instead of the dog looking straight ahead, it is looking up in the tree at the cat. That's our angle of elevation that we want to find. So first of all, we think about, we're looking for an angle. That's what we covered yesterday, finding angles using our trig ratios. Looking at the two sides that I know, which of my trig ratios am I going to use? You always use the angle. It's never the 90.
Tangent.
Okay. We're going to use tangent because we have 5 is adjacent, 16 is opposite. Okay. We're looking for this angle, so that's what we base it off of. So tangent of angle D is equal to, okay, tangent is opposite over adjacent. Need to make sure you have them in the right spot. So 16 over 5. I need to have that D all by itself. So what do I need to do to get the D by itself?
Divide by
You cannot divide by tangent, so we have to do the inverse of tangent.
Very good. Okay, when we are looking for angles, we use the inverse function. Need to know that. You can see that from your notes. But if you need to write that more clearly at the top of that page from yesterday, When we're looking for an angle, we use inverse tangent. So D equals the inverse tangent of 16 over 5. So now that is ready for your calculator. Second tangent, 16 divided by 5. For these problems, like the assignment that you'll be getting, the angles we're going to round to the nearest degree. So when I put that into my calculator and round to the nearest degree,
73.
I would round up to 73 degrees. Okay? So a 1 degree symbol, because it is a word problem, we need to have our label. So our label is the degrees, or you can write the word degrees. Number 2 says the angle of elevation from a soccer ball to the ground to the top of the goal is 34 degrees. Okay? So we've got a soccer ball, and then we've got our goal that stands up. Okay? So instead of going straight to the goal, we're going up. That angle of elevation is 34. We know the goal is 8 feet tall, and we want to find the distance from the ball to the goal. So looking at that information, I again am going to use tangent. Okay? X is adjacent, 8 is opposite. So tangent of angle 34 is equal to opposite 8 over adjacent x. So this time I'm looking for a side length rather than an angle. My variable is in the denominator. So how am I going to get that variable all by itself?
Swap tangent times 34.
Okay. When our variable is in the denominator, this is where I showed you that trick where we're going to flip those two pieces. So x equals 8 over tangent 34. So now it's ready for the calculator. 8 divided by tangent 34. For our side lengths, just like the assignment you're going to get, we're going to round to the nearest hundredth, 2 numbers after the decimal. So what do we come up with for this one?
12. It's 12.
We're rounding to the nearest hundredth.
It's
11 and 86 cents.
So 11.86. And what is our label?
feet.
Feet.
Does it tell us where we're rounding?
I am telling you right now, your worksheet will tell you. Yes.
Okay, that's what I was asking.
Yep.
Because I didn't see that in there.
Yeah. Nope, it didn't here. I'm just having you do it the way your worksheet will have you doing it. Okay? And then our angle of depression. Angle of depression. When looking down to an object, the angle of depression is formed by an observer's line of sight
Or LOS for sure.
and a horizontal line. Okay? So it's just like we did for the angle of elevation. We're just looking in another direction. Here we're up in the sky, okay, or up above something. Instead of looking straight ahead on that horizontal line, okay, our pterodactyl is looking down at the dinosaur So instead of looking straight ahead coming down, we have that angle of depression. Sometimes people get confused with the angle of depression as far as where it goes. They like to put it out here instead, okay, which is not correct. Okay. Something that can help you. It says the angle of depression is congruent to the angle of elevation. If we think of an angle of elevation, that comes from the ground. So the dinosaur, instead of looking straight ahead, is looking up. And it's telling me that these two angles are congruent because they are what? What kind of angles are those two angles?
Oh, alternate.
Opposite interior.
Alternate
Oh, I got it wrong.
interior angles.
That's my favorite.
So that information can come in handy when we are drawing those triangles, labeling our information. Sometimes it helps to be able to use that alternate interior angle. So number 3 says the angle of depression from an eagle sitting on top of a flagpole to the base of a tree is 63. Okay? So we've got this flagpole and we have a tree. The eagle is sitting up top and the angle of depression to the base of the tree is 63. So instead of looking straight ahead, the eagle is looking down, and that angle of depression is 63. The flagpole is 18 feet tall. We are looking for the distance between the pole and the tree. So when I look at that information, if I look at the triangle where I have my two side lengths, I'm looking at this yellow triangle, but the angle of depression that I have is in a different triangle. So neither of the individual triangles have information to work alone. So I need to transfer some information. So how might I go about doing that?
So you move the X onto the top where it's equal, because aren't they like meant to be parallel lines?
Yep. So I could move the X up there,
And then you can move the 18 to the other.
and I can move the 18 over there, and then I can use this green triangle. Okay. If I wanted to use the yellow triangle, I would use that we know that my angle of depression and angle of elevation are alternate interior. So either way, you're going to have the same information in those triangles. So looking again at our information, which trig ratio are we going to use for this one?
Well, we have not much. We have opposite and adjacent.
Okay.
So we're going to have to use tangent.
So again, we're going to be using tangent. Okay, we have opposite and adjacent. If you're using the other triangle, 18 is still the opposite, X is still the adjacent. So tangent of 63 is opposite 18 over adjacent X.
So switch them.
So again, we need to flip those parts around. X equals 18 over tangent of 63. So then we are going to put that into our calculator. And we are looking for a side. So again, we're going to round to the nearest hundredth. And what do we get? 9.17. And again, our label is feet.
What did we do?
What?
It told us in the problem.
What were you asking?
How do we get the angle of 63?
It's right here. It's in the problem. The angle of depression.
Angle of depression, okay.
Yep, is 63.
I thought the hypotenuse was 63.
Okay, no. Okay, last one. We have a shark swimming 28 feet below sea level. Okay, so here's our sea level. The shark is 28 feet below. If the angle of depression from a boat on the water to the shark is 19 degrees, so we've got a boat here down to the shark, that angle of depression is 19. We want the horizontal distance between the boat and the shark. So horizontal distance is that top.
We will once again be using tangents.
Okay.
No, we won't, because that's the hypotenuse.
No, it is
No,
not.
it's
Wait,
not.
no, I read it wrong, sorry.
Okay. So again, we have our opposite and our adjacent. So tangent of 19 equals opposite 28 over adjacent x.
You could also switch over.
So again, because the variable's in the denominator, we need to flip that around. X equals 28 divided by tangent of 19. And then rounded to the nearest hundredth. Our answer is
81.31 or 32.
81.32 feet.
Excellent.
So again, those angles of elevation, angles of depression, just a word problem where we can use our trig ratios.